Okay, so pre-algebra, finishing chapter 8 and then starting chapter 9. 8.6, we are still working on solving equations, but now you have a variable on both sides. Okay, so what that means is that with your equal sign, you have a variable on both sides. So like 8x plus 3 equals 5x minus 7. Okay, that variable's on the left and the right of the equal sign. So in order to solve an equation like this, you have to apply the properties of equality to get the variable on one side and then isolate it. Okay, so looking at our notes, consider the equation 7x equals 16 plus 5x. Okay, the goal of this is to isolate the variable on one side and have all the numbers on the other side. Okay, the properties of equality allow us to add or subtract the same variable term to both sides. Okay, so it's different than dividing because we're taking the entire thing. We want the number and the variable. So we're going to move this whole thing to the other side. Okay, so it's being added, so we use the opposite of the addition and we subtract it to take that entire term to the other side. And then 7 minus 5 is 2. That's how we get our 2x. Okay, then it goes to something we've solved before. You isolate by division. Okay, so a couple of examples. 5x plus 7 equals 3x minus 17. And then we'll do 3/5 y plus 3 equals 1/5 y plus 9. Okay, so this first one, right, we have x on the left and on the right. I'm going to try to make it a positive x. So if I have a negative 5x, I want to move it to the opposite side of the equal sign. So I'm going to do the opposite of negative 5, and I'm going to add 5x. So negative 5x plus 5x cancels, and you get 7 on the left. And then 3 plus 5 is 8. That's how you get 8x minus 17. Now they're like what we've done before. The variable is on one side, so I'm going to put my numbers on the other. So I'm subtracting 17. I need to add 17. So I get 24 equals 8x. Then I need x by itself, so it's multiplied by 8. So inverse is to divide both sides by 8. And I get x equals 3. Okay. This next one, right, I have y's on both sides. So this one's bigger, so I want to move this one to the left. Okay, so 1/5 y, so the opposite would be to subtract it because it's a positive. So I'm subtracting 1/5 y from both sides. Well, 3/5 minus 1/5 is 2/5 y plus 3. Cancels here, so I get 9. Okay, now it's like what we've done before. So I need to move the numbers to the other side. So I'm adding 3. I need to subtract 3. So I get 2/5 y equals 6 because I'm subtracting it from both sides. It's a fraction, so we're going to multiply both sides by the reciprocal. So 5/2 times 2/5y is just y, and then 6 times 5/2 would be 15. So we get y equals 15. Okay. 2 more of these. We have 4 times z minus 3 in parentheses equals z plus 9. And then we have 5 w minus 2 in parentheses equals 2 times w plus 4. So 2 different problems, okay? This first one, right, the first thing you want to do is you have to simplify. So we're going to get rid of those parentheses. So I'm going to distribute the 4. So I get 4 times z, 4 times negative 3, so 4z minus 12 equals z plus 9. Now we're going to put z on one side, okay? So I want to try to keep the positive z, so move the z to the left, so that's a positive z, so I subtract z from both sides. So 3z minus 12 equals 9, because 4 minus 1 is 3. Then I move the numbers, so I'm going to add 12 because that's the opposite. So I get 3z equals 21, okay? And then opposite of multiplication is division, so I divide both sides by 3, and I get z equals 7. Okay? All right. This last one, again, you have to simplify first. So I'm going to get rid of my parentheses, distribute the 5 on the left. So 5 times w is 5w. 5 times negative 2 is minus 10. On the right, I'm going to distribute the 2. So 2 times w and 2 times 4. So I get 5w minus 10 equals 2w plus 8. So want to keep it a positive w, so the 5 is bigger. I'm going to move the 2w to the left. It's a positive 2, so I'm going to subtract 2. So 5w minus 2w is 3w. Okay, then you need to go ahead and move your number, so I'm going to add 10 to both sides. So 3w equals 18. Undo that multiplication, and I'm going to divide by 3, and I get w equals 6. Okay? All right. That's 8.6. 8.7 is now just solving inequalities. So an inequality is a math sentence that uses one of the following. So not equal, because it's saying it's unequal. Okay? The left could be less than the right. The left could be more than the right. It could be less than or equal to, or greater than or equal to. Okay? The arrow always points to the smaller number. And it is open to the bigger or the larger number. Okay? When you have the equal sign, it's really just for variables in there, okay? Because these 4 is less than 9. But the equals, it would be like if x is less than or equal to 9, x can be any number all the way up to 9, including 9, because you got that equal to part, okay? So if I look at this inequality, and I add 2 to both sides. So I get 4 plus 2, and I get 9 plus 2. That turns out to be 6, and 9 plus 2 is 11. That is still true, okay? So 6 is still less than 11. So we have these same properties, okay, when solving inequalities. So with solving inequalities, addition and subtraction are the same. You can add the same number to both sides, and your inequality does not change. I can subtract the same number from both sides, and your inequality does not change. Okay, multiplication and division are a little different, okay? So just consider the inequality 8 is greater than 2. Okay, that we know is true. If I multiply by 4, so 8 times 4 and 2 times 4, well, that's 32 and 8. 32 is still greater than 8. So I multiplied by 4. If I multiply by negative 4, $32 is now less than negative 8. So when you multiply and divide, you have to consider that negative, okay? You can multiply or divide by the same positive number, and the inequality does not change. And then if you multiply or divide by the same negative number, you need to reverse your inequality. So a less than needs to be reversed to a greater than. A greater than needs to be reversed to a less than. Okay? Otherwise, the steps are the exact same. So x divided by negative 2 minus 5 is greater than 13. 13 is less than negative 6n plus 4n minus 3. And then 4w minus 3 is greater than negative 2w plus 15. Okay? Solving these, I want to get x by itself. So I start same way as if this was an equal sign. I'm going to add 5. So x divided by negative 2 is greater than 18. Okay? Then I need to get x by itself. So it's dividing by negative 2. So I'm going to multiply by negative 2. So that's how you get your x. You multiplied by a negative. So you have to switch your inequality. So now x is less than negative 36. Okay, it started as x being on the greater side, okay, but you multiplied by that negative, so now you're going to switch it to less than. All right, problem like this, you need to simplify first. So you get 13 is less than, negative 6n plus 4n would be negative 2n minus 3. Start isolating to get x by itself. I'm going to add 3 to both sides. So 16 is less than negative 2n. Now I need to get n by itself. So I'm multiplying by negative 2. So I'm going to divide by negative 2. This is a negative. So negative 8. Switch your inequality greater than n. You could switch that and then say n is less than negative 8. They mean the same thing. Okay, the arrow is pointing to the smaller number. All right, the last one, we're going to put our variable on the same side. So I want to try to keep that w positive for this reason. So I'm going to move the 2 over. So I add 2w. So I get 6w minus 3 is greater than 15. Then I need to add 3, right? I'm using these inverse operations. So 6w is greater than 18. It's multiplying by 6, so I'm going to divide by 6. This is positive, so I don't need to change my inequality. So w is still greater than 3. Okay? So inequalities, you solve them the same way, except just remember if you're multiplying or dividing by a negative, you're going to switch your inequality. And that's where your Chapter 8 test will cover through. Okay? Chapter 9, we're looking at ratios and proportions in 9.2. Okay? So a ratio is just a comparison of two numbers. Or two quantities, okay? It's comparing one to another, okay? So if I say like boys to girls, right? If there are 3 boys and 7 girls, I could write that as a ratio of 3 to 7, or I could say 3 to 7, or 3 to 7. They all mean the same thing. Generally, we're going to write them this way or this way. If you write them as a fraction, you're going to write them, or either way you write them in lowest terms, just like a fraction. Okay, so if it was 5 to 10, I could reduce that fraction, right? You think of it as 5 over 10, so it'd be 1 to 2. Okay, you have to write it in lowest terms. So you have a basketball team. And they're playing, okay? And they won 6 games. And they lost 9 games. Okay? We're going to write a couple ratios. We're going to write the number of wins to losses, and then the losses to the total. Okay? So wins to losses, they won 9, they lost, or they won 6, they lost 9. We have to reduce that. So we're going to write that as 2 to 3. As a fraction, you can write it as 2 to 3. Okay, the number of losses to the total. Well, they lost 9. The total would be 9 plus 6. So they played a total of 15 games. Okay, 9 to 15, you have to reduce that. You get 3 to 5. They lost 3 to every 5 they played. Okay? The order you write them is important. If I'm asking you for the ratio of the wins to the losses, and you tell me that's 3 to 2, that tells me they won 3 and lost 2. Okay, so that would be incorrect. So the order is important. Okay? So you have 8 clarinets to 2 oboes. So as a ratio, that would be 8 to 2, but then you have to reduce it. So you're going to say 4 to 1. Or you could write it this way, 4 to 1. You can't just write it as 4, okay? You need that 1 because it's a ratio. So John made 16 free throws out of every 20 he attempted. Okay, what is the ratio of free throws made to free throws attempted? Okay, well, he made 16 out of every 20. So 16 to 20, reduce that to 4 to 5. So either of these ways are an acceptable way to write a ratio. 4 to 5, 4 to 5, or 4 to 5, as long as it's reduced. Okay? And then a proportion is just a way to compare two ratios. Okay? So in one class, the ratio of boys to girls was 4 to 8. In a second class, the ratio was 5 to 10. Looking at these 4 to 8, I could reduce to 1 to 2. 5 to 10, I could also reduce to 1 to 2. So for that reason, we would say 4 to 8 is equal to 5 to 10. This is called your proportion. You're comparing two ratios that are equal. Okay? it's an equation that states two ratios are equal. Okay, so A over B equals C over D is a proportion. Their cross products have to be equal, meaning A times D is going to equal B times C. Okay, if this is true, so if cross products are equal, then the proportion or ratios are equal. The end numbers are called the extremes, and the middle numbers are the means, okay? So you can use your cross product to solve an equation or solve a proportion. 9 over 21 equals n over 35, okay? So it tells us that 9 times 35 equals 21 times n. And then to solve for n, you divide by 21. And I get n equals 15. We can also use the cross product to see if two ratios are equal. So if I have 6 over 10, 8 over 15, and 15 over 25. I want to decide which two are equal. So I'm going to check their cross products. So do 6 times 15 and 8 times 10. Okay, are they equal? So 8 times 10 is 80, and 6 times 15 is 90. So they are not equal. So 6 over 10 does not equal 8 over 15. Then we're going to check here. Okay, 8 times 25, does that equal 15 times 15? Well, 8 times 25 is 200, and 15 times 15 is 225. So they are not equal, those two proportions. Then I'm going to check 6 over 10 and see if it equals 15 over 25. So check the cross product. 6 times 25, does that equal 15 times 10? So 15 times 10 is 150, and 6 times 25 is 150. So they are in fact equal. So the proportion 6 over 10 equals 15 over 25. Okay? And then one more. So Ashley is going to charge $1.75 per hour to babysit. How much for 3 hours? Okay, so you would set up a proportion. You would say $1.75 per 1 hour equals X per 3 hours. Okay, so cross multiply. So $1.75 times 3 equals X times 1. So $1.75 times 3 is 5.25, and X times 1 is X. So it'd be $5.25 for 3 hours of babysitting. Okay, so that is 9.2.